The alarm bells are ringing in scientific institutions worldwide. For the first time in human history, governments are quietly acknowledging what researchers have been warning about for months. If you're not subscribed yet, hit that subscribe button now because this information could change everything we thought we knew about our existence. Comment below what you think about these shocking revelations that are being kept from mainstream media. Deep within the most advanced laboratories on Earth, instruments more powerful than anything humanity has ever built are detecting something terrifying. The Dark Energy Spectroscopic Instrument, known simply as DESI, has been peering into the deepest reaches of space for over a year now, mapping the largest three-dimensional structure of our universe ever created. What it found has sent shockwaves through the scientific community and forced government officials to confront an uncomfortable truth about the nature of reality itself. The data is unmistakable and chilling in its implications. Dark energy, the mysterious force that has been driving our universe's expansion for billions of years, is not the constant, reliable force scientists once believed it to be. Instead, DSI's measurements spanning 11 billion years of cosmic history reveal that this fundamental force is weakening, becoming what researchers describe as less pushy over time. This isn't just another academic discovery, it's a revelation that could fundamentally alter the fate of everything we know. Picture the universe as a balloon being inflated by an invisible hand. For decades, scientists assumed that hand would keep pushing steadily, inflating the balloon forever until it became so thin and cold that life would simply fade away in what they called heat death. But now, the instruments are telling us a different story. The hand is getting tired, the pressure is dropping, and the implications of this discovery are staggering beyond comprehension. Dr. Mustafa Ishak from the University of Texas at Dallas, one of the lead researchers analyzing DESI's data, explains that if dark energy continues to weaken at the rate they're observing, our universe could eventually stop expanding altogether. When that happens, gravity, the force we experience every day when we drop a pen or feel our feet planted firmly on the ground, would begin to win the cosmic tug-of-war that has been raging since the Big Bang. The timeline for this cosmic catastrophe stretches far beyond human civilization as we know it. Current calculations suggest that if this trend continues, the universe could begin contracting in approximately 20 billion years. That might seem like an incomprehensibly long time, but in cosmic terms, it means our universe has already passed its halfway point. We are living in a universe that has already begun its journey toward what scientists are now calling the Big Crunch. This isn't science fiction anymore. The measurements come from the most sophisticated cosmic survey ever undertaken, involving thousands of the world's brightest minds and billions of dollars in cutting-edge technology. DESI has mapped over 6 million galaxies and quasars, creating a three-dimensional picture of space that extends back through time itself, showing us how the universe looked and behaved when it was just a fraction of its current age. What makes these findings even more unsettling is how they align with other recent discoveries about the fundamental instability of reality itself. Quantum physicists using advanced computer simulations have demonstrated how our entire universe might exist in what they call a false vacuum, essentially a cosmic house of cards that could collapse at any moment if the right conditions are met. The false vacuum decay scenario is perhaps even more terrifying than the gradual weakening of dark energy. Imagine if the very fabric of spacetime, the stage upon which all of existence plays out, is not in its lowest possible energy state. Quantum mechanics tells us that everything in nature wants to reach the lowest energy level possible, just like a ball rolling down a hill until it finds the bottom. If our universe is sitting in a valley that only looks like the bottom, but isn't actually the deepest point possible, then a quantum fluctuation, a random event at the smallest scales of reality, could trigger a transition to the true ground state. This transition would propagate outward at the speed of light, fundamentally altering The laws of physics as it spreads, atoms would cease to function as we know them. The forces that hold matter together would change. Life, consciousness, and everything we've ever built or dreamed of would simply cease to exist, not through destruction, but through a complete rewriting of the rules that govern reality itself. Recent quantum computer simulations using 5,564 qubits have modeled exactly how this process might unfold. The results show that once begun, false vacuum decay creates a spherical region where the new, true vacuum state exists, surrounded by a bubble wall of pure energy that expands relentlessly through space. Anything caught inside this expanding bubble would find itself in a universe with completely different physical constants, different forces, and different possibilities for matter and energy to interact. Government scientific advisors have been briefing officials on these discoveries for months, though public acknowledgement has been carefully managed to avoid widespread panic. Internal memos leaked from various space agencies revealed growing concern about what these findings mean for long-term human planning and space colonization efforts. If the universe itself has an expiration date, how does that change our priorities as a species? The implications extend far beyond abstract physics. Space agencies worldwide are accelerating their efforts to establish self-sustaining colonies beyond Earth, not just as backup plans for terrestrial catastrophes, but as distributed baits on humanity's survival across multiple cosmic environments. If the universe is indeed heading toward a big crunch scenario, spreading human civilization across the widest possible area might increase our chances of surviving the initial phases of cosmic contraction. The psychological impact of these revelations is already beginning to surface in unexpected ways. Mental health professionals report increasing numbers of patients expressing what they call cosmic anxiety, a deep unease about humanity's place in an apparently unstable universe. Philosophy departments in universities are experiencing unprecedented enrollment as students grapple with questions about meaning and purpose in the face of universal impermanence. Religious leaders across different faiths are also wrestling with how these scientific discoveries relate to traditional teachings about eternity and the ultimate fate of souls. Some see vindication in ancient texts that speak of cosmic cycles and the temporary nature of physical reality. Others struggle to reconcile beliefs about divine permanence with evidence of universal mortality. But perhaps the most profound shift is occurring in how we think about time itself. The human brain evolves to consider timescales measured in decades, maybe centuries at most. Our political systems, economic structures, and social institutions all operate on these relatively short time frames. Now, we're forced to confront decisions and discoveries that operate on scales of billions of years, fundamentally challenging our ability to process and respond appropriately to information of this magnitude. Young scientists entering cosmology and theoretical physics are approaching their research with a new urgency. They know they may be among the first generations of humans to study a universe with a known expiration date. This knowledge is driving innovation in ways that pure curiosity never could. Research into alternative theories of physics, investigations into the possibility of surviving universe-ending scenarios, and speculative work on technologies that might allow consciousness to persist through cosmic transitions are all receiving unprecedented attention and funding. The data from DESI continues to pour in, with each new analysis refining our understanding of dark energy's behavior and our universe's ultimate fate. Teams of researchers work around the clock, knowing that every measurement brings humanity closer to a complete picture of cosmic destiny. The instrument's ability to look back in time by observing distant galaxies means that scientists are essentially watching the universe's history unfold in reverse, tracking the precise moment when expansion began to slow. International collaboration on these projects has reached levels previously seen only during major wars or global crises. Scientists from competing nations share data immediately, understanding that the implications of their work transcend political boundaries. The European Space Agency, NASA, the Chinese National Space Administration, and other organizations have established unprecedented data sharing agreements specifically focused on cosmic fate research. Meanwhile, technology companies with interests in long-term data storage and space exploration are quietly adjusting their strategic planning. Projects designed to preserve human knowledge and culture for future generations are being reconceptualized to account for the possibility that future generations might need to survive in a fundamentally different type of universe. Companies like SpaceX, Blue Origin, and newer ventures focused on interstellar travel are incorporating these cosmological findings into their mission planning. The most advanced computer models now running at supercomputing centers around the world are attempting to map out various scenarios for how cosmic collapse might proceed. These simulations consider factors like the rate of dark energy weakening, the possibility of dark matter interactions changing as space contracts, and the complex gravitational dynamics that would emerge as galactic clusters begin moving toward each other rather than away. Some models suggest that the early phases of universal contraction might actually be beneficial for spacefaring civilizations. As galaxies move closer together, the distances between star systems would decrease, making interstellar travel more feasible. The increased density of matter and energy might also provide new resources for advanced technologies that we can barely imagine with our current understanding of physics. However, these potential benefits would be temporary. As contraction accelerates, temperatures throughout the universe would begin to rise. The cosmic microwave background radiation that currently provides a cold 2.7 Kelvin backdrop to space would start getting compressed and heated. Eventually, this radiation would become so intense that it would prevent stars from radiating heat efficiently, leading to a runaway heating process that would make the universe increasingly hostile to any form of organized matter. The final stages of cosmic collapse, according to the most detailed simulations, would reverse the entire history of the universe in fast forward. Stars would be torn apart by tidal forces as space itself contracts beyond critical thresholds. Atomic nuclei would break down as the fundamental forces of physics get compressed beyond their normal operating parameters. Eventually, all matter and energy would converge back toward a state similar to the extremely hot, dense conditions that existed in the first moments after the Big Bang.